that contains one or more rational expressions. So let's talk a little bit about rational expressions. What are they? Because we've learned about them before. What is a rational expression? What's a one-word name for a rational expression? Fraction, right. Okay, so basically a rational expression, remember, is a fraction that involved a variable. And so what we're going to do now is we're going to now, instead of oops, I skipped one. There we go. Instead of looking at expressions, we're going to look at equations. So that means we're going to throw an equal sign in there. So this is what we're going to do. So our goal is to solve for x. Very first thing what you need to do whenever you look at these is you're going to look at the denominators. Here, here, here. Now if you remember, about a section or two ago we talked about finding the LCM of 2 or 3 terms. Reason why we looked at that is because that's what you're going to do now. You're going to find the LCM between those 3 terms. So we're finding the LCM between x plus 3, 6, and 18. What will the LCM between all of those be? So first of all, x plus 3 has got to be part of the LCM because that's a quantity. Okay. Now I have the numbers 6 and 18. What's the least common multiple between 6 and 18? 18. Okay, remember least common multiple is the smallest number that both go into. All right, 18 can't go into 6, it can only go into 18. So this is my LCM right here. So what I need to do is I need to go ahead and multiply each one of these terms by that. Okay, so I'm going to multiply that first one by 18 times x plus 3. I'm going to multiply this one by 18 times x plus 3. And I'm going to multiply this one by 18 times x plus 3. So now, in doing that, let's look at this first set of terms. Do you notice anything that can cancel? The x plus 3's. So really, I'm left with 18 times 4. Right? Anything that can cancel in the second term? 6 goes into 18 how many times? 3. So really I have 5 times 3 times x plus 3. What can cancel from the third? 18s. So that leaves me at 23 times x plus 3. Now for those of you wondering where the denominator went, we got rid of it. We did what was called rationalizing the denominator. We got rid of that. So now we just have a basic equation we need to solve. What is 18 times 4? 72. What is 5 times 3? 15. So you know what I'm going to do? I'm going to take 15 times x plus 3. And what does that give me? 15x plus 45. What do I get here? Yep. So then now all we have to do is solve. So I need to get all my numbers to one side, I need to get all my variables to the other. So I'm going to go ahead and move the 69 to the left, and I'm going to move the 15x to the right. So on the left, things I'm looking for are things I'm going to compare. I'm going to go ahead and 72, negative 69, and 45. What does that give me? 48. On the right, 23 and negative 15x. 8x. So last but not least, what does x equal? Okay. Now, one of the things about doing the process we just did is we've got to be careful that our denominator in the original problem doesn't equal 0. So if I take 6 and I plug it in right up here, do I get 0? No, I get 6 plus 3, which is what? 9, so we're good. Now, if that would equal 0, we need to cross that answer off, and we'll look at an instance of that. Okay, let's look at another one.
So if it's 0, it's like undefined?
If it's 0, you can't have it happen, because remember, you can never have division by 0. It's, as you said, it was undefined. So, Let's look at this one. So the very first thing your attention should be drawn to, the denominators. So now I need to figure out what would be the least common denominator between all of those, or the LCM. So what's it going to be? 48 times x minus 4. Very good. So now I'm going to take each individual term, and I'm going to multiply it by that 48 times x minus 4. So what do you get from your first one? 48 times 9. Very good. What do you get from your next one? 7 times 4 times x minus 4. And then on the right, I'm going to get 55 times x minus 4.
How do you do the middle thing again?
What
How
middle?
do you get 7 times 4?
Because 12 goes into 48 4 times.
Oh, okay.
So you've still got your 7 and then times 4. What's 48 times 9? 432. Plus, this really should be 28 that I'm going to take times x minus 4. So it'll be 28x minus 112 equals 55x minus 220. So let's go ahead and combine terms. So I'm going to subtract my 28x and move it to the right. And then I'm going to add my 220 and move that to the left. So what do you get when you add and then subtract your 112? You get 540? Somebody else get 540? Yep, and if I combine these, I get 27x. So now I'm going to divide by 27. And what do you get x to equal? 20. So let's go back to our original problem and see where x is. X is in the denominator right here. So if I put 20 right here, do you get 0? Nope, so we're good. Alrighty, so let's go ahead and, okay, you think you got this one down, or should we, because we're going to look at one with multiple ones. So you think you've got these 2 ones down? Okay, let's go ahead and look at this one then. Okay.
Oh, this is so much fun.
So what do we do on that second term?
Factor.
Factor. What does that factor to be?
5.
Yep, so what does it factor to be total?
Well, x plus 3x.
There we go. X plus 3, x plus 5. So in looking at all of those individual terms, so right here, 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 what's our least common denominator going to be? Good. X plus 3 times x plus 5. Good. So that's what we're going to do. We're going to multiply this by, oh, gotta have my pen first of all. That helped, wouldn't it? So I'm going to multiply this by x plus 3, x plus 5. This one I'm going to multiply by x plus 3, x plus 5. This one I'm going to multiply by x plus 3, x plus 5. All right, so what do you get from your first term? Times x plus 3. Minus, what happens here? They both cancel. Now, be careful because this is a quantity. So do you see what I did? Since that's a quantity and you're subtracting that quantity, notice I put it in parentheses. What do you get on the right side then? 3 times x plus 5.
Did you change it to an addition sign?
Yep. Yeah, and that's in fact what we're going to do on the next one. Okay. So what do you do from this first term? Distribute. So you get 2x squared plus 6x. And if you didn't catch what Parker said, I'm going to just basically switch all those signs. Okay. So I get a negative x squared. What do you get now? Plus x plus 10. Good. On the right side, I'm going to get 3x plus 15. So now, since I've got a quadratic, you can already see you've got a quadratic, we need to get everything to one side of the equation. So I'm going to go ahead and subtract my 3x, and then I'm also going to subtract my 15. Okay. Now, on the left side, let's look for like terms. Like terms, 2x squared, negative x squared, what do you get? 1x squared. 6x, negative 3x, positive x, what do you get? 4x. And then what? Minus 5, good. And that will equal 0. Now, whenever we have quadratics, we have numerous ways to solve these. We can graph, we can use the quadratic formula, we can complete this square, or in this case, we can factor. Okay, 2 factors of 5 that do what? Differ by 4. What are they? 5 and 1. What are the signs? Yep. Good. So according to this, I'm going to have 2 solutions. What are those 2 solutions going to be? Negative 5 and 1. So let's plug each of them in to see if they work. So if I plug negative 5 up here, do you get 0? Yeah, so negative 5 is out. That is one that does not work. Okay. Now I'm going to plug 1. If I plug 1 up here, do I get 0? No. If I plug 1 right here, do I get 0? No, because I get 4. And so as a result, 1 is your only answer. So that's an instance of where you get 0. You can't do it. You just cross it off. Okay, think you can handle that? Okay. Do you want to look at another one? No. Okay, we'll see how we do. Okay, this is the very last one we're going to look at, and this is going to be on your homework. Okay, so you might want to pay attention. Sarah has 10 pounds of dried fruit selling for $6.25 per pound. She wants to know how many pounds of mixed nuts selling for $4.50 per pound she needs to make a trail mix selling for $5 a pound. Let M equal the number of pounds of mixed nuts. Complete the following table. So first of all, what's going to go here for mixed nuts? The pounds of mixed nuts, what is that going to be? Yeah, M, right? Because it says M is the pounds of mixed nuts. Okay, so really, the trail mix I create by taking the dried fruit and adding mixed nuts to that. So what would the trail mix be in this case? 10 plus M, because you're going to add it together, right? Okay, so now how much does the mixed nuts cost per pound? $4.50. How much does the trail mix cost per pound? $5. Yep. So then now, how can I figure out how much I'm going to spend for mixed nuts? What will that be? M times $4.50. Good. And then here I'm going to get $5 times 10 plus M. Okay? $5 times 10 plus M. Okay, so anyway, we need to go ahead and write. Okay, we need to write a rational equation using the last column of the table. So basically, we're looking at this right here. Okay? So, write a rational equation using the last column of the table. So can somebody tell me what that's going to be? What do I know about the dried fruit, the mixed nuts, and the trail mix? The total price of the dried fruit plus the mixed nuts, that's going to equal the trail mix. Okay? So now, we're going to go ahead and solve that. So I have 6.25 times 10. What does that give me? 62.5. On the right side, what does that give me? 50 plus 5m. So now what we need to do is we need to solve that equation for m. So how you solve that equation, that will tell you how many pounds of mixed nuts that you need. So what you need to do on your assignment, and this is going to be a little different. This is on page 576. Normally we don't start with number 1. You are starting with number 1. Okay, so on page 576 you need to do 1 through 9. That is not a typo. That is the ones I want you to do.
Can you go back to
Okay.
that one problem?
So